for this unit? If you need to move your seat to see around that computer, feel free to. Just don't walk in front of it.
On the 12th day of Christmas, I'm gonna start singing that song.
I think 21 days till Santa.
Okay.
What?
My brother said that if we have one more week left for Christmas.
Tell me you wish.
Yep. And we still showed him the calendar. He was like, "It's wrong."
It's not a nice word.
Oh God.
It looks like we have a lot of pages to do today. It's really not all that much information, so please do not panic.
Can we start doing this one on 93?
93, you got it. Your title page, we're in on page 93.
One last call. If the following students are in the building, please report to the media center immediately. If the following students are in the building, please report to the media center immediately. Josiah Medley, Bianca Min.
Oh.
Bianca's not coming. She in Mexico. Not coming back till Monday.
Mendoza.
She went to Mexico right after or during Thanksgiving break.
Isn't she supposed to be in Jacksonville?
I wish I was in Mexico right now.
She's supposed to be in Jackie.
She'll be going there when she comes back. Not quite sure why. We can talk about that later.
Did I put this in our cycling?
Yes, that's fine. All right. Your title page, ladies and gents. Whoa, where did my title page go? Where's my title page?
I guess we don't have one.
You do.
My title page somehow deleted. That's okay, I can fix it.
But you make
Quick fix. Here's your title page for today. So yes, We are filling out a lot of pages, but again, the first 2 pages should all be information you should already know. And the other ones are not a lot of information. Page 98 is actually your homework tonight. You're gonna have another one of those sorting activities like we did before. Please make sure we do it this time. Okay, so we're on unit 4, solving right triangles. I have us completely mapped out till the end of the semester. We are doing lessons clear up until January 10th. January 11th is teacher-made exams. You guys do not have a teacher-made exam, so we will spend that day reviewing for your final. Okay. Also, to help boost some grades, I do something every year called your final exam study buddy. So what you're gonna end up getting is a manila envelope with a bunch of practice problems in them. You'll get benchmark 2 to look at and review, and other practice problems that I have for you. What you're going to do with it is every night you need to work on practice problems for up to 30 minutes. Okay? And your parent or guardian needs to sign off that you have done that every night from the time I give you the envelope until the time you take your final exam. The day you come in to take your final exam, you will turn the envelope into me. You can keep all the practice problems for yourself so you have them, but the envelope and the paper that your parents sign has to be turned into me. That is a free 100 test grade, as long as all the signatures are on it and you've done what you needed to do. Okay, you will get it the day before we leave for Christmas break, since we do not have a lot of time to review. Please, after school, come to me. I will go over any of those problems with you. The day before your final, we will go over any of those problems that you need me to go over. Okay, we just don't have a lot of class time to do so. Once you are done with this, we are going to start with this page, Pythagorean theorem. We are eventually going to cut it in half. You can do so now, or you can leave it. These will glue in on pages 94 and 95. Bless you. Are we allergic to math class today or just school in general?
School.
Just school in general?
Yeah, why you have to remind me?
You need to get yourself. Take one calculator.
Okay, so again, we're going to start with this page on the Pythagorean theorem. I'm going to kind of go fast through this information because, again, it should be a review of what you have done in the past. Pythagorean theorem, I believe, is taught somewhere in the
8th grade.
8th grade? Mm-hmm. And it was somewhere in the 7th or the 8th grade.
It was 8th grade because I was talking about it when we was doing Amadu yesterday.
Oh, yeah? Mm-hmm. I love her. Okay, so does anybody know what we use the Pythagorean theorem for?
Where the rectangles?
It's a right triangle What does it solve for though? Does it solve for sides or angles?
Sorry.
Sides. Okay, so the Pythagorean theorem is used for finding the length of a side of a triangle. Actually, let's put side of a right triangle. Okay, so we use the Pythagorean theorem to find the length of the side of a right triangle. It can be any side we want. It can be one of the two legs. Remember, your two legs are what make up your right angle. It's the shortest sides of a triangle. What's the longest side of the triangle called? We've got legs and a hypotenuse. Beautiful. They do not call this the Pythagorean theorem for nothing. A guy with the last name Pythagoras, okay, came up with the Pythagorean theorem. So, Pythagoras was a Greek philosopher. And mathematician. He did the first proof of the Pythagorean theorem. He's the man that started this whole thing. Don't forget, we don't just come up with math out of nowhere. You have to have proof that it works. Okay. Nobody walked in and said, hey, a squared plus b squared equals c squared because I said so. Okay. That's not what he did. He actually went through a process and proved that it works every time.
I wonder who came up with math.
To become a math major in college, you actually get to take a class called History of Mathematics, and you learn about all of the mathematicians that came up with all of our fantastic theorems that say that we can do this.
Fantastic theorem.
Yes.
They suck.
What about science? Albert Einstein.
Oh, no. It's the same thing with science too. They don't just come up with these equations.
Galileo.
Okay. All right. Here's my triangle. They want us to label the legs and the hypotenuse.
This is the leg.
What is this side here?
Hypotenuse.
That is my hypotenuse. That is the longest side of your triangle. If you can't tell that it's your longest side, how else would you tell me that that's the hypotenuse? What is it across from? It's across from your right angle. It's across from your right angle. Okay? If that's my hypotenuse, that means both of these sides are legs. Okay? You've got a short leg and a long leg. Or if you have an isosceles triangle, you have two legs of the same length. What's it called if my triangle has all three sides that are different? We have an isosceles triangle where you have two of the same sides. You have an equilateral where all of your sides are the same. What do you have if you have a triangle with all three different sides? Begin with an S.
Tetrahedral.
No. Scalene triangle. Okay, so the thing that's special about this theorem is one, it only works on right triangles. That's it. It works for nothing else. So we're going to do an example. We have a right isosceles triangle, and the legs are 6 meters long each. Find the length of the hypotenuse to the nearest tenth of a meter.
That's a mirror for a minute.
Okay, so we've got this triangle. Again, all of our triangles are right triangles. If this is isosceles, what does that mean about my legs?
They're the same size.
They're the same size. So this is 6 and this is 6. These are both equal. It's isosceles. Okay, before we continue, jump down here for a second. Your Pythagorean theorem is a squared plus b squared equals c squared. What value is a? Is that a leg or a hypotenuse? Leg. A is a leg of your triangle. B is what? It's another leg. And your C value is always your hypotenuse. Okay, so the square of both of my legs added together equals the square of my hypotenuse. So A is a leg, B is a leg, C is your hypotenuse. Okay, so if we go back up to example 1, what value do I plug in for A?
6.
6. What value do I plug in for B?
6.
And what value do I plug in for C? C squared, X squared, whatever. That is your unknown. Okay? That is your missing piece. That's what we're trying to solve for. So what's the value of 6 squared? 36. Beautiful. So 36 plus 36 equals c squared. What do you get when you put 36 together? What did you say? 72. Perfect.
And then you square root it.
And then you take the square root. Good, because the opposite of squaring something is taking the square root. So c equals what?
It's coming back to me now.
What's the square root of 72?
Not 8.
But I think I remember how to do this by now.
No.
Eight point four what?
0.48.
0.48, so let's round it to 8.5. And yes, this is gonna be meters.
Doesn't that side always have to be bigger than both of them?
Right, this side always has to be bigger than both of your legs. So that's a good way to check yourself. If this number comes out to be smaller than my legs, you did something wrong.
Was this one test?
This was on your benchmark, yeah. I didn't count these ones though, because I had not gone over it yet. Okay, take a look at this one. They give you the triangle already set up. What value goes in for A?
And 8.
X or 8, it doesn't matter. So x squared plus
8 squared
8 squared equals
13.
13 squared. What do I get when I square 8?
4.
64.
Oh.
Square it, don't take the square root. 13 squared is? 169. Okay, how do I get x by itself now?
Square root?
Not yet. What do I have to get rid of yet?
The 64?
The 64. How do I get rid of my 64?
Subtract it to both sides.
Subtract. Okay, remember every time you cross the equal sign, you do the opposite. So x squared equals 105. So to get x by itself, we must do what?
Divide.
Square root it.
Square root it. So my answer here is going to be what?
10.2.
10.2. And this is in what?
Meters?
Look at your triangle.
Feet.
It's in feet.
So your it has to be a number behind your decimal. Okay, well, never mind.
What do you mean? We're just rounding. So what do you get as the entire decimal when you plug that in? You get 10 point what? It's just flat out 10.2, there's nothing after it.
No, it's 4.
So it's 10.24.
But it's not
Because this isn't 5 or higher,
Yeah.
this stays, and it's just this. Okay. Good question. Now we're going back to rounding rules. Okay? On the other side, we can prove that a triangle is a right triangle. Okay? We can prove it because of the Pythagorean theorem. So, I have a triangle with side lengths of 8, 10, and 16. Which one of those lengths would be my hypotenuse?
16.
Why?
Because
It's the longest, okay? It's your biggest side. So let's see if we can prove if this is a right triangle. So it's going to be 8 squared because that's a leg, plus 10 squared because that's a leg, equals 16 squared. What is 8 squared?
64.
Are you kidding me? Oh my god.
What is 10 squared? And what is 16 squared? 256. Beautiful. Okay, so add these two numbers together on the left-hand side. 64 and 100 give me what? 164. Does 164 equal 256? No. So this is not a right triangle. If they do not equal, it is not a right triangle. So not only does Pythagorean theorem help you solve for sides, it also tells you whether you have a right triangle or not.
So it got to equal the same number every time.
Yes. So if you came up with something like 64 equals 64, yes, it's a right triangle. Okay. If it's a true statement, then yes, it is. If it's a false statement, no, it is not. Okay. All right. Over here, find the length of the diagonal. You're going to see, I guarantee you see something on your final exam dealing with this. Okay. So I've got this rectangle. My short side of my rectangle is 4 inches. My long side is 11 inches. I need to find the length of this diagonal. How do I do that?
You break it in half.
Okay, so we kind of break the rectangle in half. If I break it in half, I've got this triangle. What do I know about this triangle? What kind of a triangle is it?
Upside down.
It is upside down. But what kind of a triangle is it?
A scaling?
I guarantee you it's a scaling. But what does, right, it's a right triangle. Remember,
It's still
Pythagorean
right.
theorem only deals with right triangles. Because this is a rectangle, all of my angles are 90 degrees, which makes it a right triangle. So let's use Pythagorean theorem to solve. What is my A value? 4 squared plus 11 squared equals C squared or X squared, whatever you want to call your hypotenuse. So what is the value of 4 squared? 16 plus the value of 11 squared,
121.
121 equals C squared.
Missy Amado taught us a song with this. I think it was Baby by Justin Bieber.
I can try to look it up.
No.
What's 16 plus 121?
137.
137 equals C squared. And my final step is to do what? Square root, which means C is equal to what?
11.7.
11.7. And this is in
Inches.
inches. Beautiful.
That boy.
You said it was by Justin Bieber?
No, the like
I found it.
it was the
Okay,
beat from his
so the Pythagorean theorem works both ways. If a triangle is a right triangle, If they already tell you that it's a right triangle, you can use a squared plus b squared equals c squared. Or, like we did on this side over here, to prove it's a right triangle, if you can prove that a squared plus b squared equals c squared, then you can say your triangle is a right triangle. Okay, so if I bring this out, number 2 is this rule. Number 1 is this. Okay, so you can either use it to solve for a side, or you can use it to prove that a triangle is a right triangle. Okay, these ones are probably what you're more familiar with in the 8th grade. Find the distance between the points 4, -3 and -2, 1. So first off, how do I plot the point 4, -3? From my origin, I go where? 4 to the right and 3 down. Remember, it's always x, y. So here is 1 point. How do I plot the point -2, 1? 2 to the left
And 1 up.
and 1 up. Perfect. So they want us to find this distance. You could use the distance formula, but why start with something new if we already have something we can use? Okay, so let's create a right triangle. Extend this down and extend this across. Now I have a right triangle. What's the length of this side that goes up and down? 4. It is 1, 2, 3, 4. What is the length of the bottom of my triangle? 1, 2, 3, 4, 5, 6. So let's solve using Pythagorean theorem. A squared should be what?
4 squared.
4 squared plus b squared,
6 squared.
6 squared, equals my hypotenuse squared, which we don't know. 4 squared is 16. 6 squared is 36. When I put them together, I get what? 52 equals c squared. Finally, take your square root. What does c equal?
7.2.
7.2. Perfect. Okay. So if you cut these out, these should go ahead and glue in on pages 94 and 95. And while we're doing that, here's a little Justin Bieber for your life.
Here's the family. A squared plus B squared is C squared. A squared plus B squared is C squared. A squared plus B squared is C squared. Pythagorean theorem. A squared plus B squared is C squared. A squared plus B squared is C squared. A squared plus B squared is C squared.
Huh?
Pythagorean theorem.
I can. I don't know what this one is. I'm nervous.
We know you love this, we know you care. Just show me love, and we'll be there. You wanna help, you want an A, so we will help you go through the can't believe you take forever. If you play it cool, things on you. You wouldn't fail, it's not a fairy tale. Your brains in pieces.
Please make sure that you cut it into the rectangle and then cut along that diagonal and make it into two triangles.
Down, down, down. And they just can't believe the sun just comes back around. C squared equals C squared, C squared, C squared. This is the Pythagorean theorem. A squared, A squared, B squared, B squared, B squared equals C squared, C squared, C squared. This is the Pythagorean theorem. When we were 15, we had our first love. It made us so happy when she came along. She had us going crazy. She had us think a lot. She taught us radicals and some formulas. She made my heart pan. Skip a beat with the test of my CN. And it's fun in the classroom. But good to relax on the weekend. She knows she got me talking. Cause she's so educated. And now my heart is breaking because the years have been.
Yesterday, and I see you were just over there speaking at the.
All right, so we're gonna jump to page 96 in your notebook, and we're gonna use these two little triangles that you have just cut out. You should have cut that little rectangle into two little triangles. Okay, you're gonna take one of your triangles and glue it in here. And you're gonna take your other triangle and glue it here.
Do we go ahead and glue them in?
Yes, go ahead and glue them in, just like you see them. Okay, we're talking right triangle trig, so again, everything is going to be a right triangle. So you can go ahead and draw your right triangle symbols in on each one of these triangles. Guys, we gotta cut and glue a little faster here.
Come on, old paper.
Oh, this does not look like a little triangle.
Did anybody not get their set of triangles? I still have a couple sitting over here. anybody not get their set of triangles. Yeah, I have to. Alright. I must have just made it. Oh, no, there's 4 on a page, that's why. I only needed 10. We should have 2 extra. Alright. When we do right triangle trig, we have something called a reference angle. Okay, your reference angle is either going to give you a degree or a Greek symbol that I'm going to introduce you to today. Okay, has anybody seen this symbol before?
Have you seen my glue stick?
No. I've not seen it listed. Has anybody seen this lovely Greek symbol before?
Yeah, I seen it on that
No, I
contract last year, but my teacher said some of them go like really weird.
Okay, so most of the time you will see this symbol to represent that we don't know what the degree of the angle is. This symbol is called theta. Okay, you'll get more familiar with these when you start looking at colleges and the sororities and fraternities. Okay, because they use Greek symbols to label their sororities and fraternities. Okay, so we're going to label our sides of our triangle according to this reference angle. There is one side that will never ever change, and that's going to be this side. What is that side of a triangle? The hypotenuse.
Yeah.
Okay, it's across from your right angle. This is your hypotenuse. Okay, it's across from your right angle. That's never going to change. That will always be your hypotenuse. Okay. According to your reference angle, though, we have 2 other sides. We used to call them legs. Now we're going to call them the opposite side and the adjacent side. What does opposite mean? What's the word opposite mean? It's different, right? It's okay. In math, opposite is going to mean across from. So the opposite side across from my reference angle is this side down here. This side is opposite. As in, if I take my hand and cover this reference angle, does this side touch my hand at all?
No.
No. That is your opposite side. That's a good way to look at it. If you cover your reference angle, what side doesn't touch it? That is your opposite side. So, this is the leg across from theta.
At first I thought you were saying data.
Okay. And the last side we have is called the adjacent side. It's the side that touches theta. So the leg that touches theta. Okay, again, if I cover up theta, it's the side that touches my hand or the side that touches my finger, whatever you're using to cover up theta.
It's called adjacent.
It's called adjacent. What does the word adjacent mean? Right now, Elijah and I are adjacent.
Side by side.
We're side by side. Okay? Whoop. Because I'm knocking over his glue stick. Okay, okay, okay. Okay. Let's switch it up. If I go down to this triangle now, and I put theta down here, so now my reference angle is in a different position. What is this side now?
The hypotenuse. Oh, no, the adjacent.
Hold on. If I cover up
The
theta,
opposite.
it's opposite. I'm not touching it. So this is opposite. As we're doing these activities, they're going to label this O for opposite. Okay? What is this side here?
Oh, that word.
The hypotenuse.
I said hypotenuse. The hypotenuse.
They're going to use H to represent hypotenuse. And what is this side at the bottom? Adjacent. And they're going to use A to represent this side. Okay? So, your opposite and adjacent sides are dependent on where theta is. Okay? So, when theta was at the top, my opposite was at the bottom. When theta was at the bottom, my opposite was to the side. Okay? Again, your hypotenuse doesn't change. It's always across from the 90 degree. One more page of notes with me, and then you're going to go off on your own. What was your question, Anna?
So so it really matters where the little that theta thing.
Yeah.
Is located.
Wherever your
It changes
angle
everything.
is, wherever the angle that they're going to use is, that tells you where your opposite and adjacent side are. So, for
Forgive my
instance,
sins.
if I give you a triangle that looks like this, and I tell you that this angle is 37 degrees, okay, this is now my reference angle. Even though theta is not there, that's my reference angle. So, what is this side?
That H word.
The H word, the hypotenuse. What is this side?
The
The,
no, the opposite.
The opposite, because remember, if I cover this up, it doesn't touch it, so this is opposite, this is adjacent. Okay.
Just on the next page.
Yes. Okay, so the last page that we're going to do together is page 97, and this is this page.
What about the sins?
It's going to go in on the next page, but this is your homework.
Forgive my sins.
And it's not sin, it's sine. The word is actually S-I-N-E. The next one is cosine, and the last one is tangent.
Oh, the basic 10 sign.
Most people end up calling it sin the whole way through high school because they shorten it to S-I-N instead of using the whole word.
That's how big it is. They lazy.
Okay, so when we're looking at trig ratios, we're going to use this phrase at the bottom. SOHCAHTOA. Okay. If we have time, I'll tell you the story about Chief SOHCAHTOA and why they came up with the words SOHCAHTOA. So, if you looked at these pockets that we're going to cut out next, you have sine, cosine, and tangent. These are your three trig ratios. So, each one of these represents one of your ratios. S is sine. Okay? This is how you use this to remember it. Just like when you remembered your planets and you learned my very excellent mother just served us 9 pizzas.
Who?
You never use that phrase.
No.
The only one I remember is please excuse my dear Aunt Sally.
All right, so something like PEMDAS. Okay, parentheses, exponents, multiplication, division, addition, subtraction, your order of operations.
It has something to do with Sally.
Okay.
Yeah, please excuse my dear Aunt Sally.
Yeah. That's what I'm doing.
Oh no, when I was in science class, we learned my very excellent mother just served us 9 pizzas. Mercury, Venus, Earth, very excellent. Mars, Jupiter, Saturn, Neptune, Pluto. It gave you your planets in order.
I don't even know my planets.
Right.
I do projects.
All right. So, we're going to use this to solve. S in so stands for sine. We just learned O and H. What did O stand for?
Operation.
Opposite. Over. What did H stand for?
Hypotenuse.
Hypotenuse. Okay, so how we solve for sine is we take the opposite side and divide it by the hypotenuse. C represents cosine, which is shortened to COS. To find the cosine of an angle, we use the adjacent side, A, over H, which is your hypotenuse. Can you stop, please? And the last one, TOA. T stands for tangent. I guess I should have put theta in here, sorry. Tangent of my angle equals O stands for your opposite side. A stands for your adjacent side. Opposite side and your adjacent side.
What's at the end of that? N.
End of what end?
We have to put that O.
T-A-N.
Theta.
Oh,
That Greek symbol. Theta.
We have to put that in every time.
Okay, we're not actually going to solve today. We're going to look at, can you set it up? Can you decide if it's sine, cosine, or tangent? Okay, so up here, I need to expand this out just a little bit. Okay, so it says the sine of angle A. So angle A is down here. This is your reference angle, the sine of angle A. To find that, you would take your opposite leg and divide by your hypotenuse. So, what side is opposite from angle A? They use these. It is opposite of angle A.
A.
A. A is across from angle A. This side here. So, sine of A is A divided by what letter represents my hypotenuse?
HYP. Sin.
The letter that they give you on the picture.
C.
Oh.
C. They label your hypotenuse as C. So to find the sine of angle A, I would take whatever value is on side A and divide it by whatever value is on side C. Okay? The next one, they switch it up. Now I'm using B as a reference angle. So what side is now opposite if I use angle B?
B. Angle B.
Or side B. Okay, so it's B divided by your hypotenuse, which is
C.
C. So all I want you to be able to do today is recognize what's my opposite side, what's my adjacent side, what's my hypotenuse. So cosine. To do cosine, you need adjacent over hypotenuse. So they start with angle A. What side is adjacent to angle A?
Angle.
Side that is
Oh, you said
adjacent.
adjacent C.
No.
B.
Oh, B.
B. Remember, C is your hypotenuse. So that one is B over C. What?
They're doing the water fountain
Parents slow
thingy.
down, right? Have a brain. Barely slow down when you're at it. Fill them up and get out of it. I want to go get. What are you doing?
I'm so excited. We're going to have a water fountain again. I don't like walking the whole way down to that end of the hall, and that water fountain sucks.
That's how I go downstairs.
So do I. Okay, so adjacent over hypotenuse, according to angle A, is B over C. According to angle B, adjacent over hypotenuse is what? What is my adjacent side now?
Leg opposite.
A over
C.
C. Okay, so you have to pay attention to what angle they're telling you to use to label your sides.
Hold on.
I'm holding on.
So we don't use the angle they give us. But like for sine A, we use the angle that they give us at the top.
Mm-mm. It says sine of A, so you're using angle A.
And then the one that's opposite from it.
Right, the one that is opposite. So opposite from A is side A, and hypotenuse is C. Sine of B says we start at this angle, opposite of this angle is down here, and hypotenuse.
And then for the second one,
Okay, cosine is adjacent over hypotenuse, so they're telling me to start at A,
but don't use it.
adjacent, adjacent. So the side that touches it
Is the one we
is
use.
this one,
And then hypotenuse.
and hypotenuse. And then cosine of B, the side that touches it is this side, so it's A over C. Okay. All right, last one at the bottom, tangent. Tangent is opposite over adjacent, O over A. So I'm referencing angle A first. Which side is opposite of angle A?
C. Right?
Oh, it's A.
It's A. Remember, if I cover up this angle, what side doesn't touch it? It's angle A. So A over, what side is adjacent to angle A?
B.
B. You do not use hypotenuse at all in tangent. So now, if I'm looking at the tangent of angle B, what side is opposite?
B.
B. What side is adjacent?
A.
A. So it's B over A.
Okay.
Questions or problems? Okay, the last thing I need you to cut out is each one of these pockets, sine, cosine, and tangent. Okay. I will show you how we fold it because we're going to fold it a little bit differently so you can staple it in so it doesn't fall out of your notebook. Okay. Thing one should be coming back to us on the 20th, which is the day before break. Please don't forget to buy your talent show tickets as well.
Sorry, I'm artistic.
How much is it?
$2. As of right now, it's $2. They're supposed to be going up if you want to purchase them at the door the day of. And I think she said it's going up to like $4.
Yeah.
I have to help in it. So.
You're in it?
Yeah, I have to help it.
Oh, you're helping, you're not like actually performing?
These niggas, yeah.
So are you on the prom committee then? Are you on the prom committee?
Oh, with the Lisa, what's his name?
Oh, okay.
What are they acting
I
now?
don't know.
Oh, no, it's just a talent show. We've got kids that are gonna sing, kids that are gonna dance, kids that are gonna rap.
Never mind. I thought it was like a little show, like a play.
It's how they're raising money to help get prom prices down. So the kids aren't complaining at the end of the year that prom's too expensive.
I'm not coming to prom this year anyway, so it don't matter.
I honestly don't know.
Last year was $100.
Was it?
Yeah. Dominique could only buy one ticket because the person she could bring fought their own. My question is
I mean,
why,
our prom tickets were, I think, 180.
my question is why do you have to pay for a prom ticket?
Huh?
My question is why do you have to pay for prom?
How do you think we feed you at prom, hire the DJ, hire the photographer, you know, decorate? It doesn't all just poof out of nowhere. You guys pay to have your prom.
Oh, I wish I had magic.
I wish I had magic too.
I don't think I'm coming to prom for my junior year. I think I'm gonna just come for my senior year.
I didn't go to my prom until my senior year, and I went to my
Cause I don't feel
prom.
like wasting money 2 years.
I went to prom with a blind date. I didn't even know my date. It was awesome.
Was it catfish?
I would never change my prom for a thing. It was a friend of a friend, but I had no idea who he was. He came clear down from MIT,
I like that show catfish. I don't know. Coming out to
What's MIT?
And they
Massachusetts Institute of Technology. He was
especially when
in
they
college
be
already.
women in their pictures when they win.
He came down from Massachusetts to Pennsylvania to take me to prom.
Right.
He was cool. We had a blast.
There was no
He
twerking,
had
right?
hair that was longer than mine and wore a top hat and carried a cane to prom. It was awesome.
I bet you were in love, Miss.
No. It was the time of my life though, because I didn't know him. He knew nothing about me. I could just be myself and not try to be anybody else to impress anybody. Are you gonna cut these or are you going to sit there? Hello? I don't have time to wait for you, Elijah, because you're off daydreaming.
You're thinking about prom.
Okay, when you fold these, your tabs are gonna be folded in. Do not fold them clear to the dotted line. Leave a little bit, because we're gonna staple these into your notebook. Are you all right? All this
A what?
Yeah.
A what?
After like over a year. It's like over 2 He was gonna get it back from Apple. Like it took over a year for him to get it.
So that's the iPhone 5 that is the prom has?
Oh yeah, iPhone 5. Bruh. Alright. I was gonna get it too.
Okay, you're gonna keep all of these towards the left-hand side of your paper.
Alright, this is an iPhone.
That's under teeth now. 5 years ago.
Okay, you're gonna put one staple on the left, one staple on the right of each.
I'm 14.
You're right.
You wanna go there, Marty?
Okay, then you're also going to take it and put one staple at the bottom of each one. Okay, so stop for a second and take a look at what I did. Okay, each one of these. You've got one staple to the left, one staple to the right, one staple at the bottom. Okay, and they're going to go straight in a row down the left-hand side of your paper.
On page 98, right?
Yes.
So it doesn't matter if it's stapled on the other side of the page?
No, it doesn't matter. It's not going to hurt anything.
Today I know about battery and stuff.
What time?
They only do that so you can buy the wood.
9:28.
Yeah.
Yeah.
Okay. Did you guys grab the stapler from over there?
Except for the update. So,
There's the stapler.
battery lasts less. Yeah, I have 8. So, I'm getting the 8.
My mom wants me to go to prom.
Yeah, mine too.
I don't know. I kind of don't feel like it.
She gonna
I'd rather just have a little party with family at home and that's it.
Right.
Right.
Okay, the paper that I'm passing out to you now is the paper that's going to be cut and go into these pockets.
That's homework, right? Though.
Yes, this is your homework for tonight. You have 20 minutes to get started, which means I don't want to see you sitting around. Sweetheart, you can't staple like that. You have to staple with it shut.
Yeah, they could have that.
Okay. Do somebody need help stapling?
This up.
Oh. Thank you.
John, if you did it, don't say no. So maybe stick your.
Stapler.
Go ahead. See, man, just don't do
Through that,
it.
down.
Oh, okay.
And I'm gonna set your paper over here so you're not.
No.
Okay, beside each one of the tabs, I put what sine, cosine, and tangent is. Princess, I'm gonna set your back here.
Right, I don't get the point of it. Like, are you, especially whenever there's the queen and the king, like.
Okay, I want you to stop what you are doing for 1 second so I can go over one example with you and show you how you're gonna do this. So, this paper is what's going into your pockets. Okay, take a look at square number 1. Here is my reference angle. What sides do I have according to my reference angle? Side 5 is your what side?
You have that H word.
The H word, the hypotenuse. Side 2 is what? Your adjacent or your opposite?
I told you opposite.
Is
Oh,
it-
adjacent, my bad.
It's your adjacent. If I cover my reference angle, it touches. So this is your adjacent side. Which one of my 3 trig functions dealt with adjacent and hypotenuse? Was it sine, cosine, or tangent? If you need to flip back, please do. Cosine. So you would cut this out and it would go inside of your cosine pocket. Okay. So you're going to look at each one of these. So like number 2, I've got my reference angle down here. What side is X? Opposite. What side is 5?
Adjacent.
Adjacent. Which one dealt with opposite and adjacent?
So whatever,
Tangent. So you would cut this out and it would go into your tangent pocket.
so whatever the numbers is on, that's the side, like whatever the 2 numbers are on.
Right, whatever sides, like it's this one and this one because they have a variable or a number there. Okay, so those
So
are the
on this
sides.
side doesn't count, right?
Right, the side that has nothing written there, don't worry about that side.
But what about the numbers inside? Does that count?
That's your reference angle. So like 62 here, that's your reference angle. That's what you're using to label your sides.
What about 15?
What are they doing, building the
What do you
wall?
mean, what about 15?
Oh, never mind, sorry, never mind.
This is your reference angle, these are your sides. Okay? Questions?